Hello everyone. Okay, so let's just give a few more minutes for the other registrants to come in before we can kick off with the webinar. So we'll just take about maybe another minute or so just to wait around and we can start it. Okay, first and foremost, I would like to introduce myself. My name is Fazli. I'll be the consulting engineer for today's webinar. Okay, so what we'll be covering today is basically the introduction to consulting engineers will be myself and Rahmat, followed by some basics on Postgres and MongoDB, and as well as some load test comparison on the dashboard between the MongoDB and Postgres. And also be touching on data capping with MongoDB and Postgres as well. Lastly, we'll be going through the migration from Mongo to Postgres for if you have any plans in the future to migrate from Mongo to Postgres itself. Okay, just take note the data capping with Mongo and Postgres and the migration will be inclusive of a demo later. Alright, allow me to formally introduce myself. My name is Fazli. I'm the consulting engineer for today's webinar session. And of course, there is Rahmat, who is also the consulting engineer. And the both of us are actually working in the APAC region. Okay, so what do we actually do and who are we? Okay, so we actually provide in-region support for our Gold SLA customers. And what kind of support do we provide? Basically, we provide consultation, workshops, game plans, cadence calls, moving into production, and also feature prioritization. So what exactly does workshops mean? Okay, so in cases where you require additional sessions or you require like training sessions in terms of getting onboarded with Tide, or maybe perhaps you already tried Tide itself and you just want to know more about Tide, you can actually get us on board and we can set up like training sessions for the team itself to help you move forward with the certain feature that you have in mind. Okay, so let's talk about cadence calls. Okay, so how does cadence calls work? Okay, so in Tide we believe that it's important for us to actually have constant communication with our users. Okay, so that way we can ensure that our customers are actually all happily onboarded and have actually is actually using our product up to its maximum potential. Okay, we do not want users to only be using Tide for its basic features. Okay, because we actually have a lot of features that you guys can try out, and we would love for some feedback in terms of getting started with the features itself. Okay, so moving into production, of course we will kick off sessions with customers in terms of setting up the environment, or maybe moving forward how you want to deploy your type, how you want to deploy your deployment. Okay. Alright, that's enough introduction for today's session. Okay, so now we're moving into the topics itself. Okay, so the first topic will be talking about MongoDB, basically some basics on MongoDB. What is that? Okay, so MongoDB is a NoSQL database. It is a document-based database, and MongoDB is not relational and can have a dynamic schema. But MongoDB uses BSON, which is binary JSON. So what is BSON? Okay, so BSON is an alternative language to SQL. BSON is a binary representation format for structured data, which is used by Mongo. MongoDB stores its data in flexible JSON-like documents and handles structured and semi-structured data, making it suitable for a wide range of applications and use cases. MongoDB also uses a flexible data model, allowing you to store and retrieve complex data structures without the need for predefined schemas. Okay, I will touch base on this again moving forward in the slides later, so just bear in mind we're going to be talking about data models a lot. Yeah, okay. So it also supports high availability and horizontal scalability through built-in replication and sharding. So in terms of querying now, so MongoDB's query language includes support for CRUD operations, which are create, read, update, and delete. as well as more advanced querying and data manipulation operations. It provides a range of official drivers and community-supported libraries, allowing you to interact with MongoDB using various programming languages that you are comfortable with, for example. Okay, and MongoDB offers a flexible deployment model which allows you to run it either on premises or in the cloud itself, as well as providing managed database services, like I'm sure you guys have heard of it, such as MongoDB Atlas. Right, so that was some part on MongoDB. So now we're going to be talking about Postgres. Okay, so what is Postgres? Okay, in the first place, so Postgres is a relational database management system, also known as RDBMS. Okay, it is known for its reliability, stability, and extensive feature set. It follows the SQL standard and supports a wide range of data types, including numeric, strings, Boolean, date and time, and of course JSON formats. Postgres also offers the ACID compliance, and for those who are unsure, ACID compliance stands for atomicity, consistency, isolation, and durability. This is to ensure data integrity and reliability, and also supports advanced features such as triggers and stored procedures, enabling complex data processing and manipulation. On top of that, there is also support for indexes and advanced query optimization techniques, resulting in efficient and fast query execution. Postgres offers a robust data replication and supports various mechanisms, including logical replication, streaming replication, and multi-master replication to achieve data redundancy, high availability, and scalability. Actually, one of the more popular methods that I wanted to talk about is basically streaming replication. So what is streaming replication? Streaming replication is a built-in feature of Postgres that provides high availability by continuously streaming the changes made to the primary database to one or more standby replicas. The replicas maintain an exact copy of the primary database by applying the changes streamed from the primary. So in the event of a primary database failure, one of the standby replicas can actually be promoted to become the new primary, thus ensuring uninterrupted service. Alright, so now we are moving into how type looks like in terms of querying languages for MongoDB and Postgres. So on the left is actually some data that I've put in regard to some APIs on MongoDB, and on the right hand side is basically some data that I've put for Postgres itself. Okay, so this is roughly the difference in how it's going to look like in terms of the two databases that we're going to be talking about. Okay, so while the general concept of querying for specific fields is similar, the syntax and query languages are slightly a bit different between MongoDB and Postgres. Okay, so for Postgres, it has a more structured approach, while for MongoDB on the left hand side is much more free and easy, as it doesn't uses any defined schema like what I mentioned previously in terms of data models. Alright, so I'm just gonna share with you on how the two databases are gonna be different in a way. Okay, so we'll talk about MongoDB first. So since MongoDB is a schema-free database, right, it means that it does not enforce a strict structure or schema for data storage. For MongoDB, you can actually store the records, documents that have different structures and fields all within the same collection, as it doesn't really require a defined schema. However, for Postgres, since Postgres is a relational database management system, RDMS, it follows a structured and predefined schema for data storage. And predefined schema for data storage that ensures data integrity, enforces relationships, and enables efficient querying of the data itself. Alright, so this is basically a high-level comparison between MongoDB and Postgres. Okay, there are a few things that I wanted to touch base on. Okay, so the first thing that I want to talk about is basically the data model. Okay, so MongoDB follows a flexible schema-free data model where documents with varying structures can be stored within the same collection. However, Postgres adheres to a more structured and predefined schema with fixed tables and columns, therefore enforcing data integrity and relationships. So next, in terms of querying capabilities, MongoDB excels in flexible and fast document-based queries, supporting querying capabilities like nested document searches and dynamic queries. Okay, so for Postgres, they offer SQL-based querying with support for complex joins, aggregations, and filtering across related tables. So some possible use cases that I could think of for MongoDB and Postgres. Okay, so for MongoDB, they could be mostly suited for scenarios with rapidly changing data requirements, unstructured or semi-structured data, and horizontal scalability needs. It employs sharding and horizontal scaling to handle large volumes of data and high traffic loads across multiple servers. Postgres, on the other hand, is first and foremost is free. It's more for those that require strong data consistency, complex querying, and adherence to a predefined schema. It also prioritizes data integrity and security, providing robust mechanisms such as access control, encryption, and authentication. It also offers a variety of security features, including fine-grained access control, row-level security, and support for SSL, TLS, and encryption. Right, next we're going to be looking at how these two databases perform in terms of scalability. Okay, so we'll talk about MongoDB first. Okay, on the right hand side you can see two images. We'll talk about Mongo first. Okay, so MongoDB scales horizontally and is also known as horizontal scaling or scaling out. It refers to increasing the capacity of a Mongo database system by adding more servers to distribute the workload. So in this context, the database workload is divided among multiple servers, which collectively handle the data storage and processing requirements. Okay, so for Postgres, on the right hand side, extreme right hand side, they scale vertically and is also known as vertical scaling or scaling up. It refers to increasing the capacity of a Postgres database server by adding more resources to the existing server. So in this context, resources typically refers to the hardware components of the server, such as your CPU, your RAM, and your storage. Right, so next we are coming to the next topic, which is the Mongo and Postgres performance in terms of how type responds to them. Okay, so a test was performed to measure the size usages between MongoDB and Postgres in terms of storing analytics. Okay, so we're just looking at analytics here. Okay, so both are having the same amount of records. As you can see on the left hand side, the MongoDB is actually holding on to about 285,000 records, and Postgres is also having in about 285,000 records. Okay, so as you can see, there's a bit of a size difference between the two. So for MongoDB, the total size for the amount of records goes up to about 300 MB, while for Postgres, with the similar amount of records, it's only up to 175 MB. Okay, so why is there a difference? Okay, as Postgres uses a row-based data structure to store data, it organizes data into fixed schemas with predefined column types, allowing for efficient data storage and compression. This structured approach eliminates data redundancy and minimizes the storage overhead. And also there's something to add on. Basically, is that Postgres provides built-in data compression techniques such as TOS. Okay, so if you guys are not sure of what TOS is, it stands for the oversized attribute storage technique. Okay, it automatically compresses large or frequently updated data. This compression mechanisms helps reduce the storage footprint of Postgres databases. Okay, so whether it's enabled by default, TOS is actually enabled by default in Postgres. Okay, so when a table with columns is created that supports TOS, such as text, varchar, bytes, etc., Postgres automatically utilizes TOS for storing and managing large or oversized data values. Okay, so we also tested records of up to 24 million. Size for MongoDB is about 25.3 gigabytes, while for Postgres, it's sitting at 15 gigabytes. Also, with detailed monitoring, it will increase the size of each record. Okay, so for example, we have records of about 488,000 with detailed monitoring enabled. The size for MongoDB is about 1 gigabyte, while for Postgres is at 959 MB. So yes, there is a slight difference in terms of performance between the two databases. And again, no, I'm not trying to say Postgres is better, but here to share knowledge on the performance differences. As to me, both of them are equals. Okay, next we're going to be talking about dashboard loading times and the difference between MongoDB and Postgres. Okay, there isn't much of a big difference, I would say, as compared to the one we test previously in terms of load testing for analytics. So a test was performed for dashboard loading times, for example, viewing of logs on the log browser. Okay, so for this test itself, we have about 490,000 records sitting in tag analytics for each of the databases. So for Mongo, on the left hand side, it takes about 12 milliseconds to load the page, while Postgres takes about 8 milliseconds. And this is done with the values of aggregate lookups being set to true. So what is aggregate lookups? So enabling aggregate lookups will give us faster analytics lookup. Okay, so the same test was also done with more than 24 million records, and this time we set the aggregate lookups to false instead. So after doing the test, Mongo couldn't load the records on the dashboard, while Postgres took about 4,800 milliseconds to load the page. Again, it is faster as Postgres enforces a predefined schema and uses a tabular structure, which allows for efficient indexing and query optimization. Therefore, this can lead to faster data loading, especially when dealing with structured and normalized data. Alright, so now we're moving into data capping with Mongo. Okay, so for MongoDB itself, there are two methods which is currently being written in our documentation. There are two methods to manage your analytics storage. Okay, so why do we need to manage your storage actually? Okay, so the gateway actually generates a lot of analytics data, and a guideline is that for every 3 million requests that your gateway processes, it will generate roughly 1 gigabyte of data. So the two types or two methods to manage your analytics in Mongo are actually using time-based caps or size-based caps. Okay, so capping a collection guarantees that analytics data is rolling within a size limit, acting like a FIFO buffer, okay, first in, first out, which means that when it reaches a specific size, instead of continuing to grow, it will replace all records with the new ones. Okay, however, you need to take note that capped collections can't be converted back to normal collections. Okay, so that's pretty much for data capping for Mongo itself. Okay, so now I'm going to be moving forward to how we can actually achieve the similar function for Postgres. Okay, while MongoDB has a native feature for automatically expiring documents based on a specified time, Postgres does not provide direct support for automatic data expiration through TTL indexes right out of the box. Okay, so however, we can actually achieve that using other methods. Okay, you can achieve the similar functionality in Postgres by combining features such as triggers and or background workers, or by using tools like pgcron. Okay, so what is pgcron and what does it do? Okay, it helps you to schedule and automate the execution of SQL queries or commands at specific times or intervals. It acts as a task scheduler within within the database itself, and you can schedule and execute tasks without relying on external tools or services. So with it, you can actually schedule tasks on a per database or per user basis, ensuring that each task is executed by the specific or assigned users only. Okay, and also I'm going to be talking about PGSQL because it's going to be assisting us with pgcron. So they work hand in hand together. Okay, so what is PGSQL? PGSQL is a programming language specifically designed for Postgres. It allows you to write stored procedures, functions, and triggers in a structured manner, enhancing the capabilities of SQL. So one example we'll be talking about with using PGSQL. Okay, on the slides itself, as you can see, first you need to create a function that performs the log capping operation. Okay, so this function should contain the logic to identify and remove logs older than a certain threshold. So for my example, logs older than a year. Okay, so once a function is created by PGSQL, we will need to schedule the job. So to schedule the job, we can actually use pgcron to schedule it to run once a year. and you can even specify the schedule using cron syntax. Okay, so with this setup, the caps lock function will be executed automatically on the specified schedule. Okay, capping the locks by removing entries older than 1 year. You can adjust the schedule and the logic in the function to suit your specific requirements. Right, so now it's time to show you guys a demo of how we're going to be using pgcron. Okay, just to take note, this demo itself is just for demo purposes and it's not meant to be used on a production environment. Okay, do be mindful of this when you're trying this feature out yourself. Okay, so pgcron is an extension for Postgres that enables scheduling and execution of recurring tasks within the database. It is a much more, I would say, a convenient way to automate routine database maintenance, data updates, and other tasks that needs to be executed on a schedule. Tasks are defined using a syntax similar to the cron utility, allowing you to specify the schedule for task execution. Each task is associated with a SQL query or a script or a function, for example, with what we plan to create using PGSQL that we want to execute. Okay, tasks can be scheduled to run at specific intervals such as every minute, every hour, or every day, or even on a custom schedule. So once it's scheduled, pgcron will automatically execute the task based on the defined schedule that you have set. So this extension eliminates the need for external scheduling tools or scripts, simplifying the task automation process. I would say that this is a reliable and efficient solution for automating repetitive database tasks and also improving operational efficiency. Right, so next, if you take a look on the right hand side of the slides, you can see a few jobs that has been written. So we're going to be demoing this over in the demo later. Okay, so the first one, again, before we start off, I just wanted to let you guys know that this is just for demo purposes and you should take extra precaution when trying to schedule jobs. Okay, so the first job we're going to be talking about is basically a simple one. So that is a job to delete an API with the following API ID. Okay, it's going to run on every minute based on the job that I've scheduled. Okay, so it's going to delete from type APIs within your database where the API ID equals to a specified number. Okay, so next we're going to be talking about deleting logs from type analytics with the following timestamps. Okay, so for example, from January to October or January to mid-year. Okay, so it will delete from type analytics where extract month from the timestamp. Okay, so you can see 5 over there. So we're going to be deleting logs from the month of May as scheduled. Okay, so for the last one, we're going to be scheduling a job where you will delete the from type analytics where the timestamp equals to the date that you have specified earlier. Okay, so for example, in this demo itself, it's being set to 10 of May. Okay, so now we're going to be heading back to our demo. Okay, as you can see, this is my dashboard in the first place. Okay, we're gonna take a look at the log browser and see what kind of logs we have so far. Okay, we have currently set the logs from 28, which is today, to see how much logs we have in our dashboard. Okay, so we're going to be removing this set of logs, let's say from 1st to 27 June. Okay, so if we were to list down, we have this amount of logs from 1st to 27 June. Okay, so if we head back over to our command line, and this is within our Postgres database itself, as you can see, we do have a specific set of commands to run. Okay, so if you were to run a job, select a job, this shows no jobs available because I'm not running any job. But if I were to go to my history, I have a list of jobs that I have ran previously during my demo sessions, and as you can see, we do have jobs being typed over by its own job ID on the extreme left hand side. Okay, it starts to delete logs from type analytics where the timestamp equals to a specified date. Okay, as you can see, these are the amount of logs being deleted over with that set of dates that you have defined in your job. Okay, so as you can see, we have other jobs that I've run just to test it out. Okay, so for today, we're going to be running a newer job. So if we were to head back to our commands, okay, so we'll be changing the dates. Okay, we will selecting this command itself. This will be tasked to run for our demo. Okay, so it's going to be running from 1st of June up till 27th of June as the date that we have specified. Once done, you can hit enter and you can see the job has been scheduled on the first row. Okay, so now how to see more details in regards to the job, you need to take note of the job ID. Okay, so if you were to run the job command again, the scheduled jobs command again, you can see that there's a job currently running, okay, with a job ID of 7. So it's already running, and the database that's being affected is type analytics followed by the user type, which I've created for this Postgres database. Okay, so how do we check the details in terms of whether the job is running or not? Okay, so moving forward, we can check the details again just to see whether our logs are being populated, are being deleted. Okay, as you can see, there's a job ID of 7 running. Okay, so it's supposed to be deleting the logs the moment the job is running. Okay, so now if you go back to your analytics on your dashboard, if you go back under log browser and hit refresh again, just go back to your log browser, and if you select the same dates, it will show that the logs have been removed. Okay, so if you select 1st to 27 again, there shouldn't be any logs. And yes, so the logs are already being deleted from your Postgres database because of the job that we have scheduled to run. Okay, so that's just one of it on how to actually use that specific feature of Postgres to schedule jobs to run without you having to manually go in and remove anything yourself. You can actually just use pgcron together with PGSQL as a function to remove that specific set of logs, let's say from a year ago or maybe from 6 months ago. You can use that function to collate all that logs from a year ago, for example, and use pgcron to schedule the deletion at the end of the year. So that's about it for using pgcron. Okay, so next we're going to be talking about migration using type. Okay, so let's say you already have a database created, or you're starting out with Mongo as is the best option for now, and you decided to go with Mongo first. Not to worry, because along the way you can actually migrate from Mongo to Postgres. Okay, so type already has a migration tool, and from version 4 onwards you can actually start using Postgres as we support SQL databases. Okay, so we do support the following versions for Postgres as shown in the slides. But just take note, the migration tool will not migrate any logs or analytics or any uptime analytics data. So what will be migrated over to your newer database? Okay, so currently, if you were to use Mongo and set up type itself, what will be stored inside your Mongo databases are basically your API definitions, your users, your policies, user groups, or even your portal settings. Okay, so using just one single command, you can actually migrate all this information from Mongo all the way to Postgres. Okay, sorry about that. Alright, so now we're gonna go over to the demo for the migration from Mongo to Postgres. Okay, so just to take note, your logs and analytics won't be carried over to the new DB. Okay, just to add on, there's also a tool from Postgres that allows you to import logs separately, for example using pgloader. Okay, this is roughly how it looks like when you're importing from Mongo to Postgres on your terminal. Okay, so for Postgres itself, we can park the conversation to another day in terms of exporting logs or analytics if you really want to bring over logs and analytics from Mongo all the way down to Postgres. Right, so let me get back to my demo. Okay, so first and foremost, you will need to have Postgres running. So we'll check first whether Postgres is running on my VM, and you can see that Mongo is only running, which is on port 27017, and there's no Postgres. Okay, so let's check it out first. So on our dashboard, what do we have that needs to be imported over to Postgres? Okay, so you can see we have users. That's going to be imported over to Postgres, and then we have one user group, and then we have about 9 APIs, and then we have 2 policies that can be exported over to Postgres. Okay, so all this information will be brought over from Mongo to Postgres, and the entire interface does not change. Okay, so basically whatever you're seeing here will remain the same. The only thing that's different is just that your databases are different the moment you perform the migration. Okay, so if you head back to your terminal, I will need to install Postgres first. So give me a second to run this first. Okay. So in meantime, while this is working, I just wanted to share that Mongo and Postgres are actually similar. Okay, so this is in no way to put Mongo in the dark and just to talk about Postgres. Okay, this is just a feature that we have to help you with the migration from Mongo to Postgres. If you have any chance in the future to actually perform the migration. Okay, just to remember, just take note, only type version 4 onwards supports SQL databases. Okay. Right, so while this is running, I'll just share with you guys on what kind of values are needed. Okay, so basically you just need to change the storage type from Mongo to Postgres in your type analytics. Okay, so your type analytics are basically your dashboard configuration files. Okay, you will need to change the type, the storage main type, followed by the connection string to point to your Postgres database. And then with just a simple line, one line itself, that can be run from your dashboard directory, you will be migrating from Mongo to Postgres in no time. Alright, so my installation of Postgres is set up, as well as your user was created as well. So let's check. Okay, so yes, Postgres is running on the default port, which is 5432. Okay, so now let's head in over to our configuration files for the dashboard. Okay, head in over to your op directory, followed by your dashboard, and we head over to typeanalytics.conf. Okay, so once we open it up, we just need to modify the storage sections. Okay, as you can see, when we start it up, it's running on Mongo with the specific connection string. Okay, so what we need to do is we need to change it to using Postgres as well as the connection string. Just to take note, the Mongo URL must not be removed initially. Okay, so you just need to change the storage type to Postgres. Okay, so the Mongo URL still remains the same because it still requires Mongo to communicate when it's trying to perform the migration. Okay, so now let's try to change the values for Postgres. First and foremost, we'll change the type from Mongo to Postgres, and then we'll change the connection string. So let me take this first, copy the value, and paste it here. And I can remove the next two lines, which is Mongo and batch size. Just remove the whole chunk. Okay, once that's done, I can exit and hit save. Okay, So once that's done, we need to just run the tool or the command from type to actually migrate. So make sure you're still in your dashboard directory before you perform the migration, because it runs as a script from the directory. Once done and done, you can see that we have already successfully imported or migrated our contents from the Mongo database to our Postgres database. Okay, as you can see, ensure that Mongo URL is not empty, okay, because if not, it will just throw you an error. So once the command is run, you can see that the API collections being brought over are 9, and then you can see the policies that brought over are 2, and then we have 1 organization that was brought over, and 2 users that was also brought over, and 1 license collection that we have brought over from our Mongo database to Postgres. Okay, so what happens next is basically it has been verified that we have actually we have actually migrated our data from Mongo to Postgres. So if you head back over to our analytics page, configuration page, then we can remove our Mongo URL, since everything is already being migrated over to our Postgres database. Okay, you can remove anything that's related with Mongo. So these 2 lines, Mongo URL and Mongo session consistency. Okay, everything else remains the same, and you can exit and hit save. Once that's done, next we need to do is we need to just do a restart on the dashboard to ensure that it's connecting to your Postgres database. So once that's done, just do a quick status check. Once done, we need to log into our Postgres database, and we'll move on over to our tag analytics. Okay, so we're now connected, and we just list down. Yes, as you can see, we have already created the specific tables for our data that has been migrated over from Mongo to Postgres. Okay, so we have APIs, organizations, and analytics. We have developers, all those kind of stuff from your Mongo all the way up to your Postgres. So now how can we verify whether it's really working or not? Okay, so if we select the APIs, we just do a quick query, and you can see that we have a total of 9 APIs that was brought over from Mongo to Postgres. Okay, these are the same amount of APIs. So now let's just do a quick test by creating a new API and see where it's going to be stored at. Okay, so let's just name the new API for testing Mongo to SQL. Create the API and we hit save. Okay, so now we have a new API created, and let's see where it's being stored. Okay, so if we head back to our Postgres, by right it should be stored in our Postgres database rather than our MongoDB database. Correct? So if we do the same command again, we just list them down, and yes, you can see that we do have the new API being stored inside our Postgres, which is Mongo to SQL. So that's it. We have already migrated from Mongo to Postgres, as well as perform a quick check or verification on whether Postgres is working or not, and whether any newer data is being stored in Postgres. So that's about it for this session. Okay, and of course, before we end things off, I just wanted to reiterate that this knowledge sharing session on Postgres is not meant to put MongoDB in the dark, or being one-sided where I'm talking about Postgres and Postgres is good, Postgres is excellent, all those kind of stuff. It's just that we are doing a performance comparison between MongoDB and Postgres. I'm sure Postgres and Mongo has its own strengths and weaknesses, and I'm sure you have your own reasons for choosing your specific database to run with type. Okay, it doesn't matter if you're using Mongo, it doesn't matter if you're using Postgres. As down the line, if you're ever thinking of using Postgres coming from a MongoDB database, you can just give us a call or connect with either me or Rahmat, and we are happy to share with you on how to move forward from migrating from your MongoDB database up to your Postgres database. Alright, feel free to let us know if there's any additional queries. We can be reached at our emails, and do drop us any feedback if you have any. Alright, have a good day. Thank you, everyone.